Alright, so this is going to be another u sub problem. So cup C is what we care about. I care about my u, my du, my dx, and my x. So my u, for this one you can just pick either at this point. It doesn't really matter. You could always just try it out. So let's say I make my u sine of x. Then the derivative of sine of x, if you don't remember, just remember everything starts with s, so start with s, because starting s, all right? Or I like to think everything starts with Sarai, because that's my name, so Sarai. So I remember it that way, but okay, then c, and then s, and then c, so start with s and then c. And then bottom is bad, left is bad. I like to use word connotations, so top is good, right is good, and then left and down are bad. So then down for derivative. So you start with Sarai, okay? Start with s, or start at the start. Go down for derivative. And so the derivative of sine is going to be cosine, okay? So cosine of x times dx. This is always what's going to be here, all right? Let me just fix this. Okay, then solve for dx. So that's going to be du divided by cosine of x. I never solve for x until I get to this part and see if I actually need to solve for x in the first place. So then my integral, I put everything in terms of u. So I have my sine of x, but actually I made that my u. So that's just going to be u. I still have my cosine of x, but my dx, I actually put it in terms of u. So that's going to be du divided by cosine of x. And look how beautiful that is. These cancel out. So beautiful. I just get this. Look at how easy that is. And so then I do my integration rules, plus 1. So there's already a 1 there. So this becomes a 2. You divide by 2. So that becomes 1/2, right? Because it's the same thing as 1 times u divided by 2. Just pull out the 1/2. So that becomes 1/2 u squared, because there's a 1 here. You're adding a 1. And all of that plus c, because it's an indefinite integral. And so this is your answer, but in terms of u, you want it back in terms of x, so you plug u back in, so this u. So that's going to be 1/2 sine of x squared plus c, and that is your answer for this integral problem after you plug u back in.